Page 8 of functions. So we're just continuing the problems from page 4. Suppose that the f function is x squared plus 1 and the g function is 3 minus x. Find in simplest form g follows, or f follows g. So first we do g, which is 3 minus x, put it in parentheses, and then we plug it in there, which is something squared plus 1. So that's g follows f. And they said to find it in simplest form, so we need to combine this with this. So we need to do FOIL. 9 minus 6x plus x squared plus 1, which is equal to 10 minus 6x plus x squared. Okay, so that was AI. And then what about a II, or A2? So G follows F. So first thing we're going to do is F, and then we're going to put it into here on G, which is 3 minus something. And then we're going to combine those. So 3 minus 1 would be 2 minus x squared. Okay. What about B? Find the values of x such that G follows F is equal to f of x. Okay, so let's set G follows F, which is this, 2 minus x squared. Let's set it equal to f of x, which is x squared plus 1. And then we'll see when that's true. We're going to combine the x squareds together, so we're going to subtract or add x squared to both sides. Maybe that's better to keep as many positive terms as possible. It makes it a little easier. 2x squared. And then we're going to subtract 1 from both sides, and we'll get 1 equals 2x squared. And so in this case, x squared is equal to 1/2, and then x is equal to like plus or minus 1/2. Okay, so those are the two values, plus square root of 1/2 or minus 1/2, that make G follows F equal to the function F. It's only the same sometimes under certain conditions. 6a, they give us an equation here with two sides to it. Now it says for all values of x, show that a equals c and b equals d. Hint, it is true for all x. If it is true for all x, it is true for x equals 0 and x equals 1. Okay, so even if we don't understand it yet, let's use our hint here. So the first we'll say, okay, when x equals 0, we'll have a times 0 plus b equals c times 0 plus d. And so these become 0, and we get b equals d, okay, which has to be true, right? What about when x equals 1? When x equals 1, we have ax plus b equals cx plus d, except for the x's are now 1s, so it's a plus b equals c plus d. And then we already know that b equals d, so if b equals d, we're going to write a plus b equals c plus b. And then we're going to get rid of the b. We're going to subtract b from both sides, and we end up with a equals c. And all we did was use the two values, x equals 0 and x equals 1. We never used anything else. But we already know that those two have to be equal. Okay. B. Given that the function f is 2x plus 3, and the function g is ax plus b, and that f follows g equals x for all values of x, deduce that blah, 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 blah. Okay, so if f follows g is equal to x, we can go ahead and f follows g, so that would be ax plus b, and then that goes into the input of f, which would be 2 times something plus 3. And they already said that f follows g is equal to x, so we can set that equal to x. Then we just simplify the left side. 2ax plus 2b plus 3 equals x. And then we can combine the like terms. So there's the x term, and then there's the non-x term. So we have 2ax, and then we have a constant term, 2b plus 3 equals x. So now we already know, since it is equal to x, we know that the pink part here is equal to 0, and the blue part here is equal to 1. So 2a is equal to 1. 2b plus 3 is equal to 0. So 2a equals 1, then a is equal to 1/2. We divide both sides by 2, we get a equals 1/2. 2b plus 3 equals 0. We can subtract 3 from both sides, and we get 2b equals negative 3. Then we divide 2 from both sides, and we get b equals negative 3/2. And so I think we got both answers we were looking for. b equals negative 3/2, and a equals 1/2. Okay. C. Is the result in B true if g follows of f of x equals x for all x? Well, let's try that out. Okay, so let's do g follows f. So first we do f, which is 2x plus 3. And then we put that into the input of g, which is ax plus b. And we set that equal to x. So we get 2ax plus 3a plus b equals x. And so again, we have 3a plus b equals x. And we also have 2a times x equals x. Well, we can tell here that this is going to generate two equations just like last time. 2a is equal to 1, and 3a plus b is equal to 0. So a is equal to 1/2. And b is equal to, let's see, 3/2 plus b equals 0. So b is also equal to negative 3/2. Yeah, same result. Okay, so yes, it's fine. This is the last one. Number 7. Given that the function f is square root of 1 minus x and g of x is x squared, find g, f follows g. So first we're going to do g, and then we're going to do f. Okay, like that. Okay. So we've already found the answer to A. What about? We do know that the domain of f follows g is restricted because 1 minus x squared must be a positive number or a 0 number to be square rooted. So let's say that the 1 minus x squared must be greater than or equal to 0. Okay. Now let's take the factor of, let's factor this and see what are the possible critical values. We're going to get 1 minus x times 1 plus x is equal to 1 minus x squared, right? So like, when is this equal to 0? When is it greater than 0? Which is what we're asking here. So when is it equal to 0? Well, if this is 1, then the whole thing is going to be equal to 0, so that's a critical point. If this is negative 1, then the whole thing's this is going to be 0. It's going to multiply and get 0 also. So these are the two critical points that make it 0. What about between negative 1 and 1? What happens then? So if we put in a number like 0, we get 1 minus 0 times 1 plus 0 is 1. Is that greater than or equal to 0? Yes, it is. What if we put in a big negative number, or a big negative number? What happens? We're going to put 1 minus a big negative number, which would be a positive number, times a negative number, so that would be negative. What if we put into a big positive number? Then it would be 1 minus a positive number, which would be negative, and then 1 plus a positive number, which would be positive, so that would also be negative. So the answer to what is the domain of f follows g would be x is between negative 1 and 1. Doesn't include negative 1 and 1, because then it would be, oh wait, it can be 0. Look, it can be greater than or equal to 0. So we can include negative 1 and 1 also. Let's look at the range. And to look at the range, let's look at the original function. We know that the x values that we can put in here range from negative 1 to 1, including like small values like 0. And if you put 0 in there, you can see that the biggest the inside gets is 1 minus 0, which is 1. it's never going to be bigger than 1 because like whatever you put in for x, it's either going to make it illegal, and we already know that we're only going to permit values between -1 and 1. So like if you put like a small value between -1 and 1, it's going to be a number that is smaller than 1. So basically your highest value you can get out of here, 1 minus x squared, would be 1. And the smallest value you can get is if you put 1 or -1 in for x, you get 1 minus 1, which is 0. So basically, the inside of the square root ranges from 0 to 1. And the even after you take the square root of it, it's still going to be between 0 and 1. So it looks kind of like that. Okay? And that's the end of this page.